Hello, welcome to Code Design. Today we'll be discussing microservices architecture, and how it differs from traditional monolith architecture. So, what is a microservice? So, a microservice is basically a small service and independent service that performs a specific business function. So, what is a business function? Like, if you have these all are a business function, like user authentication, product catalog, order processing, payment gateway. These all are separate business functions. So, if you want to make them separate, all are independent processes, and all of them having a separate database, then we can call them microservice. And how these microservices will interact with each other? They will interact with each other by API calls or REST services calls. So, if we want to see how a microservice will look like, so if we have say this is our user, or this is our client, this is a web client or any client, and this client will go through a gateway service. And then after this gateway, we'll have these systems like user authentication system will have product system or product catalog, will have and we have say payment gateway, and each of them will have its own database, and they can be connected using topics or messaging system as well. So they can be connected through messaging system. So this is these clients basically what we can do. We can say this is a desktop client or web client or mobile client. So different kinds of clients can be there. So um, now then, when what is the traditional architecture for development? So traditional architecture is the monolith architecture. So what is a monolith architecture? In monolithic architecture, all the business functions lie into one big process. And very often we design them into different part, like we have UI packages or UI part, and then we have here business logic, and we have here data access layer, and then we have a single database for all of them. So for all of them, we have a single database, and then the business functions we are mentioning, right? They all will have in this single box, but maybe on a different package or different directory. So user authentication will be there. There will be product catalog, order processing, or payment gateway, but all of them will be directly accessing their code. Like there is no REST call or nothing. They will all sit in the same process. Since it is the same process, they can do inter-service calls. I mean, they are the same service. They can make direct calls. So from order, you can directly call product, or you can directly call user authentication service. So what is the how what is the criteria for monolith applications, right? One debug can crash the entire system. Since you see that all of them will be on a same system or same machine. um, so if your product system, there is a bug on product system, it can actually bring down all your applications like order processing and user authentication, right? And then the next, scaling requires duplicating the whole app. If you want to scale the application, you have to do vertical scaling. What is vertical scaling? Vertical scaling means basically you increase your CPUs and You increase your RAM on the machine that it is running to scale the application, or you make a whole copy, you duplicate the whole process and then deploy it into another server, and then you use a load balancer between these two copy of these big processes. So this is how the scaling works on monolith application, but still they will be using a same database. So though there will be separate instances of the big application hosted in two different servers, they or multiple different server, but they will be using the same database. And in the same database, you have those user information, then product order, all the information will be in the same database. Then deployments are slow and risky. Why deployments are slow? Deployments are slow because it's a big application. Everything has to build successfully and has to work successfully and define teams, right? So you have if you have different teams of developers and QAs. So one team is dependent on another team. Say order system has produced some bug, and then they need to fix it before you can deploy, because all the application under one umbrella. So that's why deployments are slow, and build will take more time, sometimes even hours if the application is very big. Uh, Not only building, I mean build and running all the unit tests. So there could be thousands of unit tests. So teams are blocked by dependencies. On the contrary, what we see in microservice, we can see that it runs on its own process. So microservice are small processes, right? Has its own database. Each microservice will have its own database, and they communicate. They don't make direct call because their code is separate and running on separate process. So they communicate through mainly REST APIs or microservice calls. So um, then here, what we see on microservices, let's see some of the criteria, right? Scalability, right? Um, uh, since microservices are, you break down the processes based on the business purpose, so you can scale them as you want based on the need. Say order processing, right? Say our order processing, we have so many orders in some peak hours, in some holiday time. So we can have multiple process units of order. And user authentication system, we can still keep it only one instance because maybe not many user is login, but if the order there are so many orders, if or maybe user authentication couple of instances, and but the order we can scale the order as much as we want based on the need. So scaling is independent, and resiliency. A failure on one service does not crash the whole system. Say we have a problem on the um, um, say payment gateway, right? So though payment is very important feature, but the other process will still be running and functioning, but you need to fix that payment service. So one service will not break all the services. Say there is a service for messaging. If the messaging fails, this will not be failed. You can independently fix that one and redeploy that one to fix it. Agility, team can work in parallel and deploy faster, and flexibility, different services can use different tech stacks. So that's one important feature in microservice. See, we have our business units separates and separates applications. So not it's not required like microservice that all the teams work on Java or Python in the same programming language. So here one can choose Python. So it could be order processing and user authentication in Java, and product catalog in Python, and payment gateway maybe in another language or another platform. So you have the flexibility of using defined tech stack for solving a so for solving one purpose. And tools like Docker, right, where you can create Docker image to run a instance or multiple instances of the application. And whereas Kubernetes help you to deploy in different machine, the same Docker instances is it can deploy in different machines when configured correctly. So, and a Spring Boot, of course, make them faster. So, what we can see that with these tools and technologies like Docker and Kubernetes, microservices become more popular because you can really scale the system very big when you need it to do that. And so another dependency, say you have the team, right? When team working or faster deployment. So say we do, I mean, raise pull request, right? On Git, we do or Bitbucket, you see pull request. Then sometimes if there is a big code base, then you need to wait for the whole pull request to be approved and then build and deploy. But if you have different code base, say for order service, you have different code base, and product service, you have different code base, then you can actually raise your separate pull requests and they can be merged and they can be deployed. So build pipeline gets easier and faster. And teams can work on their individual module and on their individual build pipeline. So then all of them will have their separate build pipeline. Whatever build tool you use, Jules or Jenkins or Bamboo, whatever you use. So let's look at the pros and cons of microservices. So pros, independently deployment, as we discussed, that microservice you can deploy individual service independently. Fault isolation, if one service break down, it does not bring down the whole system because they are separate services. Take step flexibility, as we see that you can use different programming language to build different modules separately or different service separately. And easier scaling. So you can scale the exact service that you need to scale, and you can scale them differently. You can have different numbers of instances of the services you want to deploy. And what are the cons? Complex inter-service communication. Yes, microservices, you need to do all those REST calls that has some network um, latency, right? It takes some network time to call from one service to another service. So sometimes they are very complex. Requires DevOps maturity. So you need sometimes more often you need a separate DevOps team who maintain all these build pipeline because you have now different code base. You have to maintain your code base. You need to maintain your build pipelines, configure them correctly, and ensure that they are working as they should be. Distributed debugging. So now your program spans through multiple instances and multiple machines. So you will need to use like Prometheus, New Relic, or other distributed tracing tools for logging. Like you can use Datadog or other tools. You can have Grafana dashboard for observability or New Relic dashboards or OpenTelemetry. So, and higher initial setup costs. So, microservice, as you know, you are breaking down the services. So, you will initially start with multiple different databases for each of the services and also different instances for each of the microservices we use. So, there is higher initial setup. So, well, are monolithic services bad? Is monolithic service bad, right? It's not bad. So if depends on your how depends on how big you think the system will be or how the user will grow, the user growth over time, right? If you know that your user growth on the system will be very slow, then you can still start with a monolithic system, a single code base, and as the user grow, you can separate them to create microservices. But if you know that your system initially will be with high load and lots of users and lots of transactions, right? Then you, I think it's a better idea to use microservices.